Clap. Thank you. I did not earn this at all. So, hi, I'm Lucy. I'm from BuzzFeed. I work as a senior data scientist there. And yeah, thank you all so much for coming. I'm going to spend this time to walk through some AI use cases that we face in the publishing world, particularly in the social publishing world. And one of those use cases, surprise, surprise, is matchmaking audiences to content. But I'm also going to talk about two other use cases as well. It's just that I wrote this title 6 months ago, so I didn't anticipate that. So for those of you who may not be familiar with what BuzzFeed is, we are a global news and entertainment company. So you've probably come across our content in some form or another in your lifetime. And we make written content, we make video content. Our content ranges from lifestyle posts to investigative journalism or to like very lighthearted listicles and quizzes. We have like a Twitter morning show. We have several like web series across different platforms. So we make a lot of different content every day. And just like many other major publishers out there, we subsist off of like everyone else sharing our content in this larger social web. Because like these days, you don't more and more people consume their media and they consume their entertainment through going on Facebook or on Twitter or another social platform, less and less people consume their media and entertainment through going to directly to BuzzFeed.com or to the publisher's website. So in this picture, you see that yes, we have a huge base of people who read our content or watch our content on BuzzFeed.com, as well as our mobile apps. But this is like a very small part of the fuller picture. Our audience reach extends way beyond this through our presence on various different social platforms. And our content creators also create content with this in mind. They'll create content specifically to adapt to Snapchat or to Facebook or YouTube. And we also have a dedicated team of curators who are in charge of finding which content to seed in each of these social platforms that we have. And they'll figure out like which audiences to match with to which content. And they're in charge of doing all this seeding. And seeding our content onto all of these different social channels throughout the web is what allows us to gain a larger audience, because that's what allows more and more people to be exposed to our content and therefore share it to their friends and then have all of that propagate into more and more traffic to BuzzFeed content. And so here's just like a tiny snippet of our Facebook pages that we own. And you might recognize some of these properties like BuzzFeed, Tasty, and they have counterparts throughout other social platforms as well. So when I say social platforms, I mean namely Facebook, Instagram, Twitter, Snapchat, YouTube, and as well as a few others. So we have a presence on about 10 plus of these. We also have across all of those platforms, we have hundreds of channels that are more specific to a certain type of content or more specific for certain audiences and niches and certain communities. And then to make matters more cumbersome, we also have 1,200 plus pieces of content, roughly, published a week. So we have more than 1,000 new pieces of new content published a week. And then so with all of this, our curators have a lot to sift through to decide where each of these posts that are being produced every day should be going. It's really, really burdensome. So how do we scale all this curation as we keep growing? So the answer is AI, spoiler alert. So we have all this curation data from past curation, past human decisions on where a post should go across social platforms. And this is what allows our model to learn. And the best thing our model can hope to be is almost human, right? And to be like a human curator. So for example, there's this video that we made for Facebook called 7 Things Only Sisters Understand. And this video, we have like a whole log of past curation decisions made for this video. And so first it was posted on BuzzFeed, on our BuzzFeed video page on Facebook. And this was like in 2015. And then a few months later, some curators decided to post it again on BuzzFeed video because it's a pretty like, because this content that doesn't, like, can be posted again in the future. Like everyone who has a sister like can relate no matter what time of the year or what year it is. And also they posted, and then some curators decided to post it to a different page called Story of My Life on Facebook, and then they posted it to a few other pages like BuzzFeed India, BuzzFeed Video again, and then the cycle, and then its life cycle continues that way. So, so this is just like, yeah, like the example of a life cycle of one post, and it will get reposted several times and get posted to different channels as well. So with all of that data, of which we have so much, we can do so much with it and train AI to replicate this kind of behavior. So one of the first use cases is surfacing relevant content for each channel. So instead of having a human have to sift through 1,200 pieces of content in a week to decide, is this relevant or is this appropriate for my channel, we get to give them like a more like pruned source of, or a pruned pool of content to pick from. And then the second use case is surfacing evergreen content. So this is like the idea of repurposing older posts that we've written or produced in the past, and then just reposting them to gain more fans who probably haven't seen this post before when we first posted a few years ago. So it's about taking advantage of older content to then post it again on our social channels. And then the third part of this is I'm going to talk about how we piece this all together so that we can automate a whole leg of publishing. And this will entail taking recommendations that are relevant, recommendations that are evergreen, sending them to a channel alongside human recommendations, and then deciding what's the best time to publish each of these pieces of content to create like a full publishing schedule in the end. All right, so the first case is how do we recommend relevant content for each channel? So the inspiration behind this problem is that, or behind this endeavor is that content too often slips through the cracks because, like I mentioned, we produce so much every day, it's hard for a curator to keep track of everything that could potentially fit their channel. So in this example, this post was something that was already seen by our BuzzFeed Politics channel curator. They decided because politics-related posts, they're going to post it there. However, the curator for our Latinx audience channel called Pero Like saw this later, too late, and said this was something that could have been appropriate for their channel, but they completely missed it. So our AI seeks out to like solve this problem, make that connection where it's broken. So bringing back this older example I already introduced, we have, for any given piece of content from the past, we know where it's been posted on the, and on what platforms and what channels within those platforms. So this is a treasure trove of training data for our model to then mimic curation behavior. So here we see that this model is posted on BuzzFeed Video, on Story of My Life, on BFF, and BuzzFeed India. So now our model starts to learn that this type of content would resonate well with these audiences. The only problem, well, one problem is that the problem of content slipping through the cracks is also inherent in this data as well. So like the fact that this wasn't previously posted on our BuzzFeed UK channel, which it could have resonated pretty well with, was just due to human oversight. It wasn't because of a deliberate decision that it doesn't fit on that channel. So we'll see some of these like erroneous negative examples in our training set, but this ends up being okay in the end because we just had such an abundance of this curation data and such an abundance of positive samples where we know what goes to what, that our existence of negative samples of what doesn't go to what eventually gets washed out and everything's okay. So this is essentially what our model becomes. It's a language-based relevance model. We feed in metadata about the post, particularly the title worked really well. And then from this, the model will learn whether it matches each channel or not. And it'll just output a probability for whether it's relevant. And so this is kind of what the model, this is a very simple diagram of what the model looks like. So you feed in a title. In this case, the post is chili dog bread ring. And this is like a recipe post. We have a lot of recipe posts. And you feed this in, and then the model will assign a probability that it's relevant to our animals channels. Our animals channel is like a feed of cute animal content for animal lovers. So here it's, I present this example because in our very first early iterations of the model, all of our like hot dog related content got marked as like 95% relevant to animals because the word hot dog is very prominently featured in the title. So this was just like a lesson to us on like using a bag of words model versus using like something that is more contextual. So we ended up using an LSTM that worked really well. An LSTM recurrent neural network. And so that ended up being what we went with. Of course, it's not feasible, it's not scalable to train one single model on every, like one whole model on every single channel that we're interested in because we have hundreds of channels. So we consolidated all of these into one single model that has a multi-label output. And by multi-label, I mean that instead of predicting that, oh, this piece of content can only match this channel out of these 400 channels, it can match many channels simultaneously within the 400, and each of those probabilities are determined independently of each other. So that ended up being really good for our use case. And here are some examples of what that looked like in the end. So for our BuzzFeed Books recommendation, so for BuzzFeed Books, the Facebook page, our recommendation model learned that Harry Potter fandom content is really popular, and bullet journaling content is also popular, even though that's not even like a book. That ended up being something it learned about the audience, as well as for BuzzFeed Style. That's another channel of ours. The curator actually told me that they've noticed that people of that who follow that channel actually really love like cynical posts about fashion. And actually our model like learned that as well because the first recommendation is I wore what I hate most in my closet and it was a disaster. So it even like learns all these like nuanced like voices of each of these channels. And then we also have like our BuzzFeed Rewind channel, which is for like nostalgia, throwback content, also had a lot of posts from like the early 2000s or reminiscing about the early 2000s. The original problem was that too much content was slipping through the cracks. So we helped alleviate that problem by offering 16 more. Our recommendations were able to provide 16% more content to post for our channels. And then also 63% of what we recommended also got posted. So this means that we did 63% of the legwork of sifting through content that our curators normally had to do in the past. So we helped them with that by lessening that burden. And then we also always monitor any long-term effects or any adverse effects of implementing a model like this. So we track unfollow / unsubscribe / unlike rate of like fans or followers on our channels. So we noticed that unlike rate remained stable over time. So that was a good result. And then I'll talk about the second case as well, which is how do we find evergreen content to recirculate? And the motivation behind this is that we want to take advantage of older content that did really well in the past because they tend to correlate with how they will perform now or in the future, given that they are evergreen content. That's something we've like noticed over time. So we wanted to build a model that will allow us to easily find content that's evergreen so that we could repurpose. And when I say when content is evergreen, I mean it could resonate with people today or in the future for many years. It's not tied to a very specific event or holiday or something that is fleeting. And so this is also allows us to publish more on or to post more on social platforms on the weekends or on days where our production is low. Because we still have a lot of readers, like on weekends, for example, but our writers are they're enjoying their weekends. So this provides us more content to keep publishing to our social pages. So here's an example of something that's evergreen. It's just a simple, silly poll post called "Do you actually have terrible shower preferences?" And this is something I think has a pretty like everlasting relevance to it. And this performed pretty well in 2016, and then when we posted it again in 2018, it still did pretty well. So how do we find, and additionally, like when you have such a huge amount of old posts from like just historically, you get to just scrape off the cream of the crop from these posts and repost them again. So they tend to be they tend to get a lot of traffic and be like the most like mega hit posts of the options you have. So we trained a model based on both content and traffic performance. So that's one plus side of working with older content that you can repurpose, is that you have past traffic performance data about it. So we set out to look at we assume that evergreen content typically will have a different trajectory in its traffic than timely content. So timely content will probably spike a lot in traffic in the beginning, and then it'll dwindle later on. Whereas for evergreen content, it'll probably continue, like it'll probably keep getting traffic in a more stable way. So we figured, like, let's look at current traffic divided by total traffic for every post to see if it's evergreen or not. And then just like, and initially we thought, let's just rank this and then just take the top N by this ratio, and that's probably like our best evergreen content. But if that were the final solution, I wouldn't be presenting this at an AI conference. So that ended up having some limitations, so we didn't go with that eventually. It tends to preference content that gets really high search referrals, which makes sense because then it'll keep getting continued traffic even after it was first posted. But looking at just high search referral content means like it tends to be like recipe or lifestyle hack content, which is a little more narrow than we want our content to be. So we ended up putting all this like traffic data and just metadata about the content itself, like the title, and feeding both as features into this model, this deep neural network that outputs the percentage probability that's evergreen. So that ended up working out well. But I haven't even talked about our training data yet. So this was a big problem. We don't have that much equivalent human curation data like we did in the last use case, because reposting behavior is actually pretty sparse, and it's something we want to do more reposting, but it's not something we've done enough of to train a whole model on. So we decided to go with a rough proxy to label our to assemble our training set. And the way this worked was that we handpicked we handpicked social channels that we thought were more evergreen leaning. So it's social channels that tend to post more lifestyle or relatable story content or nostalgia content. And then we handpicked some channels that tend to post more like political news and celebrity and entertainment news content. And everything that was posted on those channels, we labeled it with a timely label. So these ended up being the two buckets we had in our training set. But of course, this posed a lot of problems too, given that not every, these channels aren't as homogeneous as we assumed they were. Our BuzzFeed news channel mostly posts timely news, but occasionally it'll post some evergreen content itself. So it wouldn't make sense. So we ended up having a lot of poorly labeled data because we have evergreen posts that we labeled as timely in our training set. Like this example here, 30 powerful pictures that define American history is definitely evergreen. So we had to implement something else to handle that poorly labeled data. So we so we modified our loss function in our model to handle aleatoric uncertainty. So I guess one example of aleatoric uncertainty is like if you're doing object classification on images, but these objects that you're trying to classify are like obstructed by a wall, or if the lighting is really bad in the image. And so there's just a lot of uncertainty in that particular training point. But you don't want the model to stress out too much about those training points, so you relax the loss function as a function of the variance of those training points that your model's having difficulty predicting, or it's a variance of your model's predictions for that training point, sorry. So eventually the loss function gets attenuated by the variance of your model's predictions, so your model does get relaxed by these really difficult to predict points that are just laced with uncertainty. And so that ended up improving our results a lot, at least qualitatively, looking at what was outputted as a result of this. And so here are some examples of what our results ended up looking like. So here are just some timely evergreen predictions. I think these look pretty good. So the impact was that, so we tested the performance of our evergreen recommendations on our social channels to see if that added any boost in like median clicks, and it did. And then also our unlike rate of our social channel remained stable over time. So how do we put this all together so that we can automate this entire leg of the publishing process? So the idea is that we take all these different inputs on which items to post on which channels. So that comes from our relevant recommendations model, our evergreen recommendations model, as well as our actual human input. So all of these three sources curate some items to post onto the channel. It goes through this routing service, which then funnels them all into this model that determines when the best time to publish is for each of these items and on the given channel. And then from there, it deliberates a full publishing schedule. So the idea behind this about like determining best publishing time for each item is that our curators have come to us with like their own observations they've made anecdotally, which included that there were certain hotspots in the day where posts would get more engagement, and that especially for certain types of posts for certain times of the day. So they said that they've noticed that like posts that are like gross or about lewd things tend to perform better at night, and they hypothesized that this was because people are not going to read gross content while they're at work in the middle of the day. So this was one of their observations that propelled us to look into this. So we did some analyses and found we found that our analysis suggested that there were certain hotspots for certain pieces of content on some channels. So we decided to just put together a model that can help us determine what those optimal publishing times are. So this was just a deep neural network that takes in publishing time as a feature, as well as the channel as a feature, and then the post as a feature, including all post metadata. And the idea is that you would feed these into the model. The model would learn and predict what some KPI will be as a result of this combination. So in this case, we're just looking at the first hour shares. And then for any given post that you want to publish on a given channel, you take the post metadata, the channel, you combine it with you toggle the publishing time to try out many different possible values. You feed that all through the model, and then you get a prediction on like how well that post is going to do based on the publishing time in the channel, and then you just pick the one with the highest output. So how do we validate these models? So you're probably wondering why I haven't mentioned any like accuracy scores yet for like this model, for the model's fit, because you might think that's like super whack that I haven't done that yet. So the main reason is because the training data that we're going off of, that we would be cross-validating on, is itself not a source of ground truth. And so here are some examples of where that wouldn't help us at all. So our training data thinks that this title about the Westminster Dog Show doesn't belong to the BuzzFeed Animals channel, but our model thinks it does, which I would side with the model on this one. And here are just some other examples where our training set is not reliable enough for us to solely depend on like cross-validation on that training set. So this is all to say that the loop isn't complete with humans. And so this actually ended up being a really beneficial workflow. So we were able to narrow down which posts we think would be suitable for a given channel. And then the curators can then, instead of evaluating 1,200 posts a week, they only have to evaluate maybe 100 a week. And so this is still part of their workflow to evaluate every single post one by one to see if it's fit for their page. But now that load is lessened a lot. And while they're just doing their normal day-to-day work by evaluating these posts, they can actually, we can take that feedback that they're giving us through those evaluations and feed it back into the model. So this is very beneficial for us as well, and for them, because we can take their feedback, and one of the ways in which we did this was by building the Slack bot that serves them all these recommendations for their channel, and they could vote whether it's a good recommendation or a bad one. And then we could take that and then feed it back into our model and into our training set for our model. And in the training set, we can upweight those rejected recommendations. And we upweight them because, our rationale is that it's the only data in the training set that's human validated, so we'll upweight it. And that actually ended up improving the performance as well. So this is the full workflow for that. And so with the human in the loop, of course, we still cohabitate with humans no matter how much of their workflow we're making more efficient. And so the human decision part of it will still also always be key because our AI wouldn't be as very equipped on its own to go into new frontiers of publishing. It'll be harder for an AI to discover new formats and memes to use or discover or create new brands or break out into new platforms. So the experimentation piece that's done by humans is still very essential. And here are just some examples of mega hits from BuzzFeed from all time that came about from human experimentation that an AI wouldn't be so capable of discovering on its own. And that's it. Thank you so much. All right, should I?
We have a few minutes to do Q&A if anyone's interested. Is there a couple? All right.
Hi, you didn't mention using traffic features at all in the first use case. Is that because you tried them and you couldn't make them give you any improvements?
Yeah, so it's a good question. So it's because a lot of that content in that first use case, or all of it, is all brand new content, so we wouldn't have any traffic data on it yet.
So that there's no benefit from looking at really short time windows immediately after posting to see if something's going to exponentially take off or whatever?
So that's something we could do, but it was actually it ended up not so it ended up being just extra work that wouldn't yield us that much more of what we needed, because we want to build out the simplest solution possible. So it ended up just using titles alone was really gave us what we needed.
Cool, thanks.
Yeah.
Hi, great session. So whenever new videos are created, do you add additional metadata to them so that they can be used as attributes for training later on?
I'm so sorry, can you speak more slowly?
So when you are training something, there are multiple attributes on which you are going to train that data, right?
I'm so sorry, can you say it again?
Okay, for example, you are doing the natural language processing for some of the videos, and probably you are using the name of the video to figure out what it belongs to, what category it belongs to.
Yeah.
So are there additional attributes which are set when the video is created?
Additional...
What are the other attributes you are using?
Oh, attributes, okay. Yeah. So for the first use case, we ended up trying out other attributes like the text of the content itself, but that actually ended up performing worse than using titles alone. And then in the second model, we also kept it very simple because we learned that titles were actually a better summary and therefore a better feature to use than using all the text in the body of the content. So we only added like a few extra things, which was like what the author is, maybe like the caption of the post. So very like minimal additions.
Thank you so much.
Yeah.
All right, we can continue asking her the questions. Big round of applause for the speaker. Thank you.